No. This being problem. That's where I should. At least nothing to do. We're gonna go. A little bit like
okay, let's start. We're already 5 minutes behind schedule, so I guess it's time to start. So welcome to all. I'm glad to see you here. Welcome also to people online. And so I'm Marc Schoenauer. I'm Emeritus Senior Researcher at INRIA, Paris, France. I'm also the scientific coordinator of the Adra-e CSA transaction. So we all know that there has been a tremendous progress in the recent years, months, weeks in AI, data, and robotics. So this opens new opportunities, of course, but also brings new challenges, and specifically for Europe, that's somehow squeezed between the US and China. So the challenges are really to keep our industry competitive while sticking to our values of democracy, trustworthiness, ethics, in general. And Europe has made a series of initiatives in that direction. And there have been in our Horizon Europe projects that have been launched in 2023. And also, the other side, there have been this ADR, so the data robotics partnership. The partnership has somehow given birth to the Adra Association. So the association, which is the private part of the partnership with the European Commission. Together with Adra and together with the project, so the Commission also funded 2 CSA, support actions. So Adra-e, which I have the honor to coordinate, and AI for Europe. You will hear Bahare Salehi soon talking about AI for Europe. That's responsible of the AI on-demand platform for research. So why are we here today? Well, the idea is, this is also the mission of Adra-e, try to, let's say, coordinate the whole community, particularly because AI data robotics used to be, still are to be, 3 different communities. The idea is to make them one single community, aiming to have the goals I mentioned. And so this 2-day workshop will be focused on trying to leverage the project results and also make the link with what is called in Adra the topic groups, which are working groups around very specific topics. So they will be made of 2 days. Today is focused on the project, and you will have the opportunity to gather together upstairs in the breakout session in 4 clusters this morning and 4 other clusters this afternoon. And tomorrow is more topic group oriented, so I have a topic group, and you will have similar breakout sessions with 4 topic groups in the morning and 4 in the afternoon. After hands-on experiments with the for tomorrow. So the goal of all these workshops, each session workshop, is to try to really make take advantage of these 2 different poles, which are the project and the topic groups. In particular, to identify what are the next challenges, what are the rising areas, already existing areas, and to integrate them in the next iteration of the SRIDA, which is the Strategic Research, Innovation, and Employment Agenda, which was the cornerstone of partnership. This should be updated very regularly because it's very, very fast pace of the technology today. And so we want to, after this meeting, try to gather also this input for the SRIDA and the integration of SRIDA. And this includes in particular the convergence of these different projects between them, strategic objectives, so mapping that will help also the Commission to define next content of next program. Okay, so I will not be any more longer. So as I said, today we have this project-oriented day with the breakout session, and in the end of the day, we will have some debriefing of these workshops in 2 subsessions of 40 minutes each, approximately. That will help trying to really identify these new challenges. So we have the pleasure to have with us Stacey Luet from DG Connect, head of the AI and Robotics Excellence Unit, tonight for the closing session, and tomorrow of the opening session. Okay, without any further ado, let's switch to the first session. We have 2 keynotes, Bahare Salehi, professor at University College and coordinator of the AI for Europe CSA, sister CSA, then Philip as well, association. So,
right, so thanks everybody for attending, and great thanks to the organizers for choosing such a fantastic location and fantastic venue. So obviously, Marc mentioned that Adra-e and AI for Europe are sister projects. You'll be hearing throughout the next couple of days another sister project that's been born, Deploy AI, which is the another CSA that supports the AI on-demand platform. So just to sort of set the scene, the AI on-demand platform was born about 5-6 years ago. The project called AI for EU, coordinated by Thales in France. And so some of you in the audience were members of that consortium. That project has been picked up by AI for Europe with a target audience of the research community. And just in the last several months, another CSA supporting the platform called Deploy AI has been started. That's really focused on the public sector and industrial community. So, without further ado, I'm going to give you a sense of the AI demand platform. So I say that because the terminology is might sound complex. So there's a thing called AI On-Demand platform. And that is outside, in some sense, any project. There are projects supporting it, so you might be part of a project that is interacting with the platform. AI for Europe is one of the CSAs on the research side. AI is a CSA industry sector side, essentially. But the platform is the platform is yours. Suzanne, my colleague from AI for Europe, is in the audience. She's leading the initiative around governance. If you're interested in being part of the governance structure for the AI On-Demand platform, please let myself know, or Suzanne. I'm not sure exactly where Suzanne is. There she is over there. She's got a hand up. So if you want to get involved in any aspect of the governance, Suzanne is the lady you need to speak to, or myself, and I'll introduce you to Suzanne. And so this is a community initiative. It's your platform, so please do get involved. So I'm just going to give you a sense of what the platform is from a very, very high level perspective. Tomorrow, Lan Fan, who's over here on the right-hand side, and maybe there, she and I, along with a number of others, will be talking to you about the sort of technical aspects of the platform. So, so first of all, let's see. So maybe I can say the next slide, and the person back in the room can move to the next slide. There we go. Oh, there we are. So the vision. So what is the platform supposed to do? Well, it's basically a place where we want to support a thriving European AI ecosystem. So it's a central hub in a sense where you can disseminate your results, where you can present your organization, where you can avail of services to do things like run experiments, build pipelines, build prototypes, and share those. And that's achieved through two mechanisms. So first of all, we want to bring the community itself, so create a platform where researchers and SMEs and tech providers and projects can basically come and do their work, digital innovation hubs, TEFs. So also, if you're a digital innovation hub or you're a TEF, please seek out the AI for Europe people, myself, Suzanne, people at the desk, Lan Fan here. We'd be delighted to talk to you. And also, it's a place where if you're a project developing a service of some sort, so for example, a service might be something to, let's say, well, one of our services is to allow people to run experiments and to reproduce experiments. So if you wanted to build some sort of matchmaking service or some sort of tool for discovering or measuring statistical bias in a data set, that's a service you can make available on the platform. And so the vision is basically to empower you, the AI community, to benefit from and share the fruits of the labor that goes on in projects. And so there are three pillars to this. So the first pillar is what we call the metadata catalog. What this is, so the way to conceptualize the platform, at least informally for now, is that at the core of the platform there's a resource called the metadata catalog. It contains essentially all of the information that the platform is aware of. So you might have a data set that sits on GitHub or a bugging phase, or you might have an AI course, a training program that sits on your university's website. You can describe those to the platform, and they are registered in the metadata catalog. And the metadata catalog is accessible through a Python API, so you can build an application that basically interacts with it, uploads information into the platform. But also because there's a lot of information in the platform at this point, and hundreds of thousands of data sets and services and tools and courses, you can build things on top of that using the API to build your own service. And so this is the core part of the platform, and this is the thread that crosses the boundaries between the AI for EU project, AI for Europe project, and AI project. So if you're interacting with that, you're interacting with the platform, regardless of which sort of community you're part of. The second pillar is the idea that so the platform itself has very limited HPC resources. CSA is quite small. But if you are a data center owner and you want to make available some high performance infrastructure, you can do that through the API of the platform. And also as a single sort of shop front to the AI community, there's a single sign-on facility. So the ECAS sign-on that you use for interacting with the European Commission, you can use that very same credential here on the platform. Your institutional credentials are probably giving you access to the platform. And again, because it's a single sign-on facility, regardless of whether you come to this from the AI for Europe side or the Deploy AI side, you can still be logging onto the same platform. So why should you join us? Well, once you're in, you can do lots of things. You can, first of all, you can develop and deploy different components, services and tools, so you can integrate them with this API. You can do all sorts of interesting things. You can interact with the catalog, as I mentioned. And if you want to, if you're a new project and you don't want to spend the time developing your own project website, you can post it on the on-demand platform. There are nice templates for doing this, so you can do that automatically. You can also use it as a dissemination channel, so you can promote the work of your project. In fact, the Commission really strongly encourages that. So they want this to almost be the also the repository of the data machine for new projects. So when you complete your project, ideally the resources and the outcomes and the results would be stored somewhere on the platform through the metadata catalog. Through projects like Vision, and you remember there was a set of research networks talking about which is still in existence, coordinated by the Vision project that Marc and I were part of. So this is the these are networks like Taylor and the Lees and so on that you might have heard of, and there's many of them still running. So as part of that initiative, there is a doctoral academy called IDA, the AI Doctoral Academy, and that is basically generated hundreds of courses, short courses, long courses on AI. These are all stored on the AI on-demand platform. So now that there's a legal requirement under the AI Act to provide literacy training, this is a great resource for you to go and develop your own courses or to reuse material that's already been developed. You might want to find and use interesting methods. There are hundreds of thousands of data sets accessible through the AI on-demand platform. You can build your own. You can run experiments there using services. You'll hear about that tomorrow. So it's a great place to go and maybe upload your own data sets. You can also use many of the hundreds of thousands of data sets already. So basically, who are the platform? I described at the very beginning who are the two projects. So I coordinate the AI for Europe project. Jochen Kohler from Fraunhofer is coordinating Deploy AI. Suzanne is a great sort of connector. She's involved in both, but she again heavily involved in the governance of the platform. So if you want to be involved in that, please do seek out Suzanne. She'll talk to you about that. And so huge numbers of research bundles, thousands of AI assets, hundreds of thousands of data sets. And if you'd like to join us, please do. We'd love to work with you. So thank you very much for your patience and your time. Thank you. We're going to have a full session. Piatkievicz, Secretary General.
All right. So, good morning, everyone. Thanks very much for coming along this morning. Looking forward to speaking to some of you later in the day and tomorrow. So, I'm going to present some of the elements of Bahare Salehi, just Adra-e organization, the association, to give us give you a little bit of the context to why we exist and the challenges that we're facing, the journey that we're on, the kind of organization around response. Hopefully also the opportunity to kind of join us in this book as well. So in the first instance, Europe is standing at the crossroads of technological leadership. And we are seeing that the kind of ongoing digital transformation AI plays a really, really significant role. Has triggered this kind of global competition for technology leadership. And there's a need for Europe to some of these developments, because I think that it's very vulnerable to this kind of across all sectors on growth and competitiveness, and it compromises the region's inclusion. So there's been a huge reaction to this number of high-level reports of stated the need for Europe to kind of rethink these things. And really importantly, we have to capitalize on the market opportunity that AI offers, the productivity gains that it gives, and also its role in responding to some of our societal challenges. So climate change, demographic shifts, reduced career ratio, lower productivity, these are all things responding to. And AI data and robotics hold immense potential to improve people's lives and significantly accelerate efforts to achieve sustainable development. What we're also seeing is that, as well as the developments within AI itself, we have a recent announcement from DeepSeek in the way that we managed to significantly innovate models, AI agents. We're also seeing a trend where AI is increasingly embodied. So organizations like OpenAI is primarily software, and NVIDIA is primarily processing, are increasingly interested in what developments in robotics might offer. And you may have seen at CS the presentation just presented this kind of evolution into the physical domain. So that's one of the negatives. So how do we respond to some of these challenges? And I think we Adra believe that to play into our strengths, to do that. And there are some elements that we can really talk about, and I think we're seeing improvements in. So in particular, Europe has some world-beating areas. For instance, our public services, health, energy, aerospace, these are all industries that are globally competitive and world-class. And we also see that the ecosystem in Europe, the technology ecosystem, is gradually becoming more interconnected, more kind of more able to attract talent, attract capital, etc. And it's these strengths that we need to start to play into. And one of the ways that we think we can do this is in the creation of partnerships to kind of stimulate an alignment between both the interests from both sides. This is one of the main reasons for this information, and to support development sovereignty, a competitive industry, the kind of fundamental research, and importantly also the kind of societal impacts. So there's Adra. Adra is basically a community of excellence. It offers a single contact point with the European Commission. It's an integrated network. It brings together all these different interests to stimulate both research, but also market opportunities, commercial opportunities for AI data robotics stakeholders. So I talked a little bit about these strategic documents from Draghi, from Letter, from Heitel, that have forced us to reflect a little bit on our situation and what we can do differently. And within Adra, we're also taking this challenge quite seriously. We have a number of working groups that are organized across different verticals, and also different horizontal interests. And they're all considering this challenge on how, what are the kind of priorities that we need to be kind of tackling and also how can we work differently across that stakeholder base. And how do we look to activate, bring to life this kind of AI ecosystem of excellence, also mentioned before, Bahare and Marc. So the AI Act itself has formed the basis of how we do kind of trustworthy artificial intelligence in Europe. And on the other hand, we have the AI ecosystem of excellence that comprises Adra-e, AI factories, the networks of excellence, the AI on-demand platform, the EDIs, etc. And so how do we bring this ecosystem to life so that the functions that it supports organization as they mature and they're able to benefit from. And within Adra, again, we're having the same conversation, looking at some of the strategic elements required to do this. And for us, they come in the form of these 5 strategic pillars. So in the first instance, we need a very strong North Star, this strategic research, innovation, and deployment agenda. One of the vision that public and private interests should be orientated towards high impact pilots in industry. So how do we stimulate this integration between AI, software and hardware convergence? Where are the really strong use cases to roll out this technology? Thirdly, based approach. This is a more efficient way of delivering funding and create challenges around some of these use cases, how to quickly cycle through the technology readiness rules and get a product from the lab bench into a commercial setting as quickly as possible. Fourthly, international standards and also the harmonized standards of the AI Act. How do we support those stakeholders implement what's happening in the AI Act, but ensure that on an international level, these are industry standard on an international level. And finally, I think this is quite critical, we're all critical, but I think this one is particularly it's about the fragmentation between member states and European level, and how we gradually move towards an alignment between those two factors. So I'm going to tell you a little bit about our team. So this is our board of directors. They are very well embedded in national ecosystems, and they're all working towards the objectives that are set out. And this is our team, very, very quickly. They're all here, so you have the opportunity to say hello. And so just really quickly in summary. So we're kind of building Europe's AI data and robotics ecosystem and creating an integrated strategic network. It's about driving collaboration between all levels of the value chain. How do we advance the strategic initiatives and making sure that we're focusing on areas that are really based on Europe's strengths and framework conditioning, and finally, it's about having impact and making sure that we actually create some societal, economic. So if you have any interest in getting in touch and being more involved in our please. Thanks very much. Bonjour.
big part of the Datanexus cluster. And then you have the branch at the web. And don't forget after lunch, 30. And you will have this session right after lunch. So then we will certainly have perfect opportunities to play. We will have a question for Harry. It's time to lunch. So, c'est bien la session.
C'est bon? Merci. Oh, non. Voilà. Merci.
That's what I was clear.
Can I?
You can proceed.
It's gonna go.
When having plans for the students come with codes and everything, I put everything on the. It's so bit worse.
Yeah. Okay. Now let's see what they see.
Oh.
Oh.
I'll find you a share. Can you see something?
I don't see. Yep. Yes, I can see.
Or no?
Wait. Yeah, I see them.
Okay, just back to station.
Yes, you hear me well. So welcome. This is our session of our cluster, Datanexus cluster. And we'll be presenting a short session here on extreme data to AI insights, the Datanexus approach across the compute continuum. I'm Janine Garrick from the Barcelona Supercomputing Center, and I'll be moderating the session today. So we are a cluster of 7 projects. These projects are all under the funding call Horizon Cluster 4 2022, and it's extreme data mining, aggregation, and analytics technologies and solutions. We share a goal of developing better technologies, tools, and solutions for data mining of extreme data. So this goes beyond big data. It's data that is high in volume, velocity, and variety. And AI relies on this large-scale complex data to learn, adapt, and make predictions. Challenges associated with extreme data require approaches that span the entire compute continuum. So edge, cloud, high-performance computing. And so these are things that the cluster deals with. And the projects that are presenting today are 5 of our 7 projects that are part of the cluster. So we have Emeralds, Extract, Graph Massivizer, Near Data, and Cyclops. And they'll be presenting a little bit about their projects. They're presenting different approaches to extreme data and through highlights of what's been going on in the first 2 years of the project, as well as challenges. And so we're going to go ahead and start with our first speaker, which is Bahare Salehi from Emeralds.
Hello, everyone. Good morning. My name is Bahare Salehi from Université of Brussels, ULB. And today I'm presenting Emeralds project, which started about 2 years ago, and we're in the beginning of the 3rd year, the last year. So it will end in this December. In this project, we are focusing on urban mobility data. And the goal is to design and develop a tool set for analyzing this data and generating a tool set that will be useful for cities and mobility data stakeholders to manage data, store it, collect it, and analyze it, and help them for real time and also historical using historical data for decision making. So basically, we're focusing on urban mobility data here, which is very challenging and complex to work with. It's high variety data from latitude and longitude coordinates. It's complex. It's actually sensitive. The security is an issue here because we are monitoring people movements. But if I want to highlight the main challenges we are facing with in this data, with mobility data, urban mobility data, I can mention these challenges. Data heterogeneity and the data collected from different sources in urban area, from sensors located in transportation networks to buses to trams, cars, people mobility, parking lots, different areas, and coming with different formats from GTFS, the real-time data, to GPS, to especially temporal. So it's make it very hard to combine and integrate all of this data all together and work with and fed it to AI models to get the insight of the mobility patterns. And the next 2 challenges are high volume and high velocity in urban mobility data, high extreme size and high rate of sampling data, which in a short time, a large amount of data generated, which make it hard to work and deal with this data. And in Emeralds, we are offering services and tools to efficiently work and deal with these challenges. Okay, if I want to, in a glance, say what is the technical situation, what is the technical idea of Emeralds. I can say it's a toolset, it's an environment that includes advanced AI and machine learning and state-of-the-art techniques, methods, and easy to deploy. Working with historical and also real-time data, and it's design and work in different type of commuting from cloud to far to edge, and also it includes a visual dashboard for which is make it easier for end user to analyzing the results of AI model and machine learning models. And as I said, we are in the last year of the project, so we already implement the key parts of the environment and apply it on our use cases and get good results. And actually, I mentioned to list here as some of the services we have already implemented in this environment. In the first list, you can see the tools and services for data processing and analyzing the mobility data. Like I don't know, map matching tools, compression data and compression tools, traffic estimator, traffic predictor. And in the second list, you can see our efforts for data infrastructure and the framework we generated in this team, like, for example, analytic toolbox or machine learning models deployment framework. Oops. And how we evaluate these tools, these methods? We are focusing on 3 European cities, and each of which has its own goals and scenarios. The first one is Hague in Netherlands. In this use case, we are focusing on improving safety and security measures during events. During events which part of the city face problems, we expect crowd or overcrowded places in events. We want to predict that by monitoring the crowd in that city. And the second use case is Rotterdam, again in Netherlands. And the goal of this use case is to reduce traffic congestion and improve traffic flow in the city and highway area of Rotterdam by monitoring the traffic flow and managing and predicting the future steps and helping actually a smart city management in this city. And finally, we have a Riga use case in Latvia. And the goal is that to design, optimize public transportation by optimizing routes, optimizing and monitoring crowds, and also decreasing emission in that city. So we have 3 cities. For each of them, we have different goals. For each of them, we have different scenarios. So we design different workflow for each use case and try to match the already designed service and tool sets for each use case. I try to just share some overview of each use case and workflow for a bit design for each one and not get too technical here. And for the first one, for the use case, which the goal was a risk assessment. We have different data sets like visitor data, parking lots data sets, events and weather data sets that help us to estimate the upcoming events. And we pass it to our platform and first empower and enrich the data by some services like data fusion and feature processing, pre-processing. And then we pass it to the next tasks like predicting parking occupancy prediction and crowd density prediction. And finally, after that, we can predict in long-term and short-term the situation, the next event situation in the city. And for Rotterdam, which the goal was multimodal integration and traffic management, we can have different data sets like highway speed and flow, weather data sets, floating car data sets, passing through the services like data imputation and weather enrichment to empower the data, and then pass it to the next services and tools like speed and flow prediction, queue estimation, and then we share the results in the interactive dashboard visualization with the final users. And finally, the same happened for Riga. We have different data sets like e-ticket data, public transportation data, real-time GTFS of situation of the buses in the city. We pass it to services like data fusion to combine this data all together, trajectory data comparison, privacy error data integration to then apply it for feed it to the services like crowd density prediction and travel time analyzing. And as the others, we share the results through the dashboards to the end users. So that's from my side. Thank you for listening.
Great, thank you so much. So next we have Abstract. We have Xavier Palomo from the Barcelona Supercomputing Center.
Okay. Well, good morning, everyone. As Inés said, I'm Xavier Palomo from Barcelona Supercomputing Center, and I will be presenting Extract, which is an European project that we have been working on for the last couple of years. So first of all, what Extract is about is we aim to create a distributed data mining software platform for extreme data in the entire compute continuum. Of course, as you know, an infrastructure composed of HPC, of cloud, and edge resources. So the goal is that once we have different kind of tasks, maybe we have some embarrassingly parallel or a task that requires high computation demands, we probably want to execute that on the HPC. If we have some tasks that have real-time constraints, maybe it's better to do that on the edge, where the data is usually generated. And if, I don't know, maybe we are dealing with a lot of data and we need to deal with a lot of data sets, probably want to do that on the cloud. So Extract, what it aims to do is to provide a task-based workflow. So from an application, we subdivide it into tasks and see which parts can be parallelized and deploy them where they are best fitted for. So here in the realm of Extract, we are also working with two very different use cases. In the first one, which is called Tasca, we are collaborating with Observatoire de Paris, an astrophysics center in France. And in summary, because this use case is subdivided into different sub-use cases, but in short, what we are doing is helping them in all the processing stages. So from the way they collect data with their antennas, to how they process it, to, for example, treat this data and then end up generating some images, which is usually the final output, and also even to the amount of data they use, they save. Then in the other use case, which is quite different in nature, so in the city of Venice, which given its peculiarities and its geography, there might be some parts of the city which can be hard to access at some point. We are collaborating with the city council to create what we are calling a personalized escaping routing system, meaning that in case of some disaster, be it, I don't know, a flooding, a fire, a terrorist attack, or any other kind of disaster, each citizen receives to their smartphones the directions which he or she must take in order to reach a safe spot. Okay, this sounds simple, but it really isn't, because first of all, we need to train our reinforcement learning, in fact, a multi-agent reinforcement learning, because the agents are the citizens, and since they interact with each other, so the decisions of one can influence the others. So we need to train this model. Then for that, we also need the urban digital twin, which creates a representation of the city, and also simulator that keeps generating a lot of possible scenarios to train that model beforehand. Then when the actual disaster has occurred, we of course need the inference, which is some final training, some fine-tuning of the model for that particular use case. And we need also other aspects such as geolocalization, because we need to understand where people are moving, how the city is evolving in near real time. So we need a lot of high computation demands. Okay, so having explained a bit what Extract is about and the use cases, let's now focus on the main results that we can provide. So first of all, from the computation standpoint, we are creating a global unified view of all the infrastructure. So as I said, we can deploy tasks where they are suited for. And for that, the first thing that we need is an intelligent scheduler that decides where we can deploy the task, where it is more efficient to do so. And also for that, we need some kind of monitoring that understands the status of the infrastructure or the application needs, so that it communicates with the scheduler to do so. But I will talk about more this later. Then second highlight, I would say, is that at least to our knowledge, there didn't exist any task-based parallel programming tool that met all our requirements. So in that line, we are using COMP, which is a tool developed at BSc, but it is open source, so anyone can use that. But we needed to make some adaptations. So first of all, it was only meant to run on Docker, so we had to adapt it for Kubernetes. This was a minor update. But maybe more importantly, COMS works on a master workers role. So as you can imagine, this might not escalate very, very well as we keep increasing the number of nodes and the number of clusters, because the role of the master could easily get overrun. So in that line, we added a third level of hierarchy in what we are calling the master primes, meaning that we only have one master overall, but one of the clusters has this master plan, which takes control of the master and some of the workers. So in that sense, we, let's say, deploy some of the tasks or the importance of the master to these master plans. And yeah, this makes it more scalable. Finally, on the results, similarly to what I was saying before in the first result about having this global view in computation terms, this global view also applies for data as well. So we don't want the burden of having to deal on, I don't know, having different storages. So we are using S3 compatible technologies, be it Mini or SEP or simply an S3 API, so that any node can access at any point each data set, regardless of where it is. So for that, we also have the data infrastructure with tools such as DataPlug or Lithops that, of course, Pedro will talk about, and is more expert than me. And also a very important one is SkyStore, which is a global, let's say, a joint project by University of Berkeley and IBM. That what it does is to cache the objects in advance. So into either local or closer storages, so that when we need to access these objects, they might already be closer, and we significantly reduce the latency. Then moving on to the challenges. The first thing we had in mind when we started working on Extract was that we wanted to hide as much as possible the complexity of the underlying infrastructure to the end user. The reason for that is that the end users might be very varied. The thing is that Extract aims to be a platform, not a solution for a particular use case. So in that sense, the end users might be very varied. For example, just going over the two use cases I briefly presented, in one of them, the end user would be just a citizen receiving instructions to their smartphones, while in the other one, it would be a scientist using Extract. So a scientist, in fact, this is one of the first things we heard from one of our colleagues from Observatory de Paris. So something in the line of the scientists should no longer be stuck processing terabytes of data, but should replace them using their knowledge without caring about the background logistical details. So in other words, a scientist doesn't want the burden of having to SSH some machine or STP for some data, or having to launch a lot of commands. He just wants to focus on what he's good at. So this is something that we need to think of when we design the solution. Then the second one is in the line of interoperability. So as you can imagine, we are dealing here with a lot of software integrating it, a lot of components. Just going a bit over the infrastructure at a high-level overview. On top, we have everything that relates to data. So as I said, object storage, tools such as Lithops or DataPlug. Also, we have the data catalog, which is useful because it's like a repository of metadata. And it also helps in, for example, when we train a new machine learning model, when we have a new version, in a sort of publishing subscriber method, we can notify all the interested stakeholders so that we are aware that there is a new model. Then beneath, we have maybe we could relate to where machine learning models live, also everything that relates to this complex orchestration workflow. And then we have everything about the scheduling, the deployment, and the monitoring to decide where to deploy the tasks. And finally, we have what we would call the physical layer, so the actual resources. And across everything, we have, of course, security. So the security ranges from either at the data levels, because we might encrypt data, we might encrypt the models if it is requested, and also at the cybersecurity aspect of the infrastructure. So all that is saying that we need to integrate a lot of technologies, and this sometimes creates friction. So first of all, in that sense, Kubernetes is an enabler. By means of containerization, we can somehow reduce this problem, but still maybe some tools that might run on the HPC cannot be easily run on a constrained edge resource. Or even maybe some software that only run on ARM architectures, but maybe not on Intel ones, or the other way around. So at the end, we most of the times end up having to do some kind of trade. Finally, I've been talking about how we have achieved this global infrastructure, but this doesn't mean it's easy. So first of all, we need some kind of technology. I wouldn't say a barrier, but there's some difficult technology here, or some difficult barrier that we need to go over, which is the fact of connecting all these clusters, because they have to have visibility among them to be able to deploy tasks. Here we tried several alternatives. I just can name a few, such as ClusterLink, Vico, Scarpark, Armada, Submariner. We tried many things, but at the end we are using Lincoln. Okay, that it's not so relevant. I don't want to go over technical details, but even assuming that this is already solved, the fact that we need to deploy some tasks to one place or another, it's not easy to decide upon, because from the scheduler standpoint, first of all, we need to take care and know which are the node resources that we have, what are the characteristics, for example, RAM, the virtual host, and so on. But then also we need to understand what is the resource usage at any point, which is the expected latency. Even we could go as far as even to energies or energy cost constraints. So the scheduler needs to understand at any point what is the current status of the system. So for that, we also need some monitoring layer that keeps track and gathers all the possible metrics, both at the application and at the infrastructure levels. And this has to be tightly communicating with the scheduler. So, well, that was it from my side. Thank you all for your attention, and I'll be happy to answer any questions you have later on.
Great, thank you very much. So now we have Radu from
Thanks. So this is Graph Massivizer. It's a European project that I coordinate. It has 12 partners, and we are over almost 5 million euro. And we build basically a holistic platform for graph processing. So these projects previously, they presented you, extreme data, but it's kind of an abstraction of, streams of data raw data that you collect over the internet. They don't talk about the representation of the data. And well, one of the most versatile representation that mathematicians invented, typically, usually, I think it started with Euler in the post-Renaissance, is the graph representation, entity relation. And if you look in the world, you see graph data structures everywhere. We have molecule graphs, atoms and bonds in between. We have a transportation network. So we heard in the Emerald projects here, we have transportations there. So here we build a fundamental technology for processing such transportation data. We have social networks, the largest application on the internet nowadays. Everybody has a social network account. So we have billions of vertices and hundreds of billions of connections. World Wide Web, the biggest network that connects us. It's also a graph, 50 billion pages, 1 trillion links estimation. And of course, the holy grail of AI is to model the human brain. It is also a graph of 100 billion neurons estimation, 100 trillions of connections. So in Graph Massivizer, we want to build a platform that has in the center what we call massive graphs. Massive graphs are graphs that scale to billions of nodes and trillions of edges. And well, we want to exploit progress in the outdated AI we call today. So the symbolic AI, semantic data and knowledge representation that used to build knowledge graphs. We also have property graphs, and we also have general graphs that are also used in HPC for doing a more realistic benchmark of supercomputers on the real world data structures, not matrices, tensors, but real sparse graph representations. And in Graph Massivizer, we build a holistic platform that supports the cycle of graph processing, starting with ingestion of the data. So you ingest extreme data, then we build an extract, transform, load pipeline based on, again, LDS, so from the semantic data to graph representation. So we do some declarative mappings that construct automatically graph representations of extreme data. On top of that, we build analytics. We want to build AI, machine learning technologies that don't apply on matrices, as usually the deep learning architectures do, but they apply on graph data representations. So here we want to go in the direction of graph neural networks. And below that, we build an automated processing platform that starts with, first of all, optimizing the workloads. So we want to model hardware, and we interconnect them between hardware with predictable time, energy consumption that support graph algorithms. We want to scale that at the data center level using sustainability metrics, also, of course, using simulation. And finally, we want to have a serverless technology that enacts the entire process on the computing continuum. So basically, this is the cycle from data integration to graph analytics, workload modeling, energy sustainability awareness, plus serverless processing. So this is graph massivizer in a nutshell. Now, in terms of use cases, we have 4 use cases plus a 0 use case that we use as a pilot. It's an academic use case. A company called MetaFacts is operating that. It's open source. So basically, it has about 26 billion RDF triples. It models academic networks. Yeah, so we crawl a lot of scientific publications, cooperations between academic people, and we build a graph of cooperations. What we are doing in this graph now, as a proof of concept, is to predict collaborations. So basically, we want to predict what would be your best collaborator in the future if you want to be successful. Yeah, we try to help you with that. An idea that we are currently doing is to crawl borders. So the network of European projects, in the knowledge graph of European project, and then predict what would be the next successful project in the next goal. So if you want to be successful, we can recommend you the best partner, yeah, to be funded. Okay, but we also have some industrial use cases. So one is from the finance. So we want to build financial graphs, and on top of that, we train financial algorithms. The company basically struggles with the fact that financial data is expensive and sparse. So we want to generate synthetic financial data that is cheap and can train highly accurate financial algorithms. We have foresight use case. Basically, we crawl through social networks, through news sites, and we try to predict disruptive events based on the history. We also work with Bosch, basically body in white, so assembly of cars. We try to, the big problem there is the welding spot that breaks. So we have here the knowledge graph representation of the entire construction pipeline, and then we want to apply green AI algorithm that model such body in white construction processes. And finally, we work with Cineca, the Italian supercomputing center, to build a data center digital twin. It's a graph, yeah. So trying to model the job, the graph, the nodes, the interconnects, the users, everything that builds an ecosystem of a data center of supercomputer as a knowledge graph. Probably it's relevant for Barcelona as well. Yeah. We work with Cineca, but Barcelona also. Okay, and they are very diverse in terms of the V's. Yeah, and we even invented viridescence, that's a green, yeah, data processing. Okay, so highlights now before challenges. So what are the highlights? So we release data sets, so big, massive graphs as open source data sets. So in addition to the same OpenAlex, so the academic collaboration network, we also released the data center digital twin knowledge graph as an open source. So we have 11.6 billion of nodes and 68.6 billion of pages. Yeah, and that's only a fraction of the entire operation, a window. So this can be scaled temporarily to a much larger graph. And also in terms of raw data, we have a Marconi 100. So that's the old supercomputer in Cineca. It's released with over 400 gigabytes of open data zipped. And so the largest data center operational trace available currently. And we want to expand this to Leonardo. So Leonardo is the follower of Marconi, and now currently we are working with Bologna and Cineca on applying the technology to the newer supercomputer. Then we released already the tools. So we have these 5 tools that we released. You can download them from GitHub website. Prototype still. We are moving now towards integration and final project release. And we build community. We are very active academically in community building. So we have a GraphSys workshop series. We used to do it with a performance engineering conference. Now we do it Europar for those who are familiar, so you can follow the workshop. We have a touch to seminar now in April. So this high profile workshop, academic workshop that builds, connects high profile researchers. So we will meet on a holistic graph processing systems seminar in April now. And finally, we have also activities in training. We are teachers, so we do a summer school since 3 years in Romania, in Predeal, so we are trying to continue on that. In terms of challenges, so what do we see? We are more fundamental research project. So we like to call them neurosymbolic. So we merge the symbolic tradition of data representation, semantic web, big data. We tend to forget that they exist, knowledge graph, and try to merge that with deep neural network that exists today. There is a big gap so far in between these two communities. So deep neural network apply on tabular data, on tables, yeah. We have to move away from that. We have to operate on graphs. And we see that as an opportunity. Finally, apply AI in all non-Euclidean space. Yes, so you don't apply on arrays, on trace or speculative apply graph. And finally, we want to do explainable reasoning. Yeah, so rather than having the machine learning model as a black box, single-step induction, we want to do like what LLMs, for example, do today: chain of thought, tree of thought, graph of thought. Yeah, trying to decompose the reasoning process into more atomic but traceable units of reasoning. Yeah. So basically, that's what we see as challenges for the next program.
Thank you very much. So next we have near data. So next we have near data, and we have some request from the University, and he is the coordinator of the project.
Thank you. So let me present near data. So near data stands for Extreme Near Data Processing Platform, and we are 10 partners. We are also on our third year. We have partners like Dell Computing, but we also have the European Molecular Biology Laboratory and Technical University of Dresden. The project is based on 4 open source projects: GitOps, Schoenauer, Braviga, and Metaspace. So we will have high TRL. We don't have research prototypes. We have results that are used by hundreds of users now, apart from the research that we are doing. So the goals of near data are 3. The first one is to provide high-performance near data serverless data connectors. The second one is about real-time video streams. And the third one is about creating a confidential data block. In general, the concept of near data is very simple to grasp. So it's computation close to the data. And this is all you know about locality. But we are dealing with extreme data that is high volume. I mean, you cannot just move these extremely big volumes like petabytes or terabytes. I mean, normally you have to compute close to them. And you know the concept of data gravity. So sometimes because of volume, you have to compute close to this data because you cannot move these things out of this location. Other reasons can be privacy. Sometimes you cannot move data because of privacy reasons. Others because of low latency, like when you are in the edge. And others when you need hardware acceleration. So near data concept in our case is very simple. We really need to compute close to the data. And we need to provide solutions that solve these problems in an easy way, like in extreme data analytics, and to deal with really complex formats, like huge blobs that are not easily partitioned and managed in cloud, HPC, or edge compute. And we also have challenges on confidential data access and serverless and HPC computing. We have 3 major use cases. All of them are focused on health. The project has a use case on metabolomics with the European Molecular Biology Laboratory. This is a cloud edge scenario where we have Metaspace, that is the biggest platform, the biggest data hub on metabolomics on the cloud, used by hundreds of users around the world. We also have genomics. We have here different partners like Barcelona Supercomputing Center, Sano Medical Center in Poland, or we also have UK Health Security Agency on genomics. And we have, again, like metabolomic genomics, you have huge blocks, and the size of these volumes is extreme. And finally, we have surgery. We have in Dresden, we have real-time surgery, where we have like video analytics that is using a streaming with extreme low latency and with AI models that must identify parts of the video to help the surgeon and the robots to operate on this data. So we have these intensive challenges on data analytics, confidentiality, and data management on these three use cases. We are in the third year, so we have a clear vision. We have like three major goals. One is around LeafOps serverless data analytic platform that we are going to offer in the next month in Pyram.cloud. This is a public service where you will have like different serverless data analytics tools in Python, not only including LeafOps, but also a serverless version of Task that's called Rapid Task, where we are offering genomics, metabolomics, astronomics, geospatial pipelines in a very efficient way. We also have an elastic stream analytics and semantic search platform on top of the Praviga Dell open source project. Praviga, if you don't know, it's a competitor to Kafka, and it's offering elastic streaming services. So you can also have this as open source, and we have like AI-driven semantic search and serverless vector DBs in the surgery use case. And finally, the third pillar of results in near data is the confidential data broker. We have here Schoenauer, that is confidential computing on enclaves. We have a startup that is Contain, that is commercializing this in Germany. And we combine here federated learning and TEEs for the genomic use case, but also in the surgery use case. So we have here a distributed confidential broker. Then to summarize the three results, the first one is LeafOps offered in Pyram.cloud. This is a multi-cloud offering, so LeafOps can run on any public cloud, like maybe Amazon, Azure, Google, Alibaba, but it also can run on premise on Kubernetes. LeafOps is also running on HPC. And it's a really simple platform. It's a serverless platform that simplifies data analysts to process these huge amounts of data, because what it's doing is automated resource provision. You don't need to be expert to provision resources. LeafOps is doing that for you in any compute infrastructure. And it's optimized for the use cases that we are doing. Here we also must outline data plug. We have created a data processing library for these specialized formats in genomics, in metabolomics, in astronomics in the extract project, and in geospatial data. So we have many use cases, and we have many formats like cloud optimized data types and non-cloud optimized data types here. There is a big list. And what we enable here, and these platforms can be used from LeafOps, Dask, Rai, Spark, and PyTorch. And these platforms are enabling that you can partition dynamically these blobs close to the data, and then accelerating pre-processing like many times, and reducing data transfers by 200%. So we are really efficient in dealing with these specialized data formats in the cloud. Then we are also offering elastic stream analytics on top of Praviga, and we are connecting here AI models that analyze video streams on surgery, and generate embeddings that can be processed in streams with very low latency in Praviga, obtaining high throughput and long-term cloud storage. And we obtain really latencies below 10 milliseconds in all cases, and 42% to 176% lower than a real-world AI inference jobs, with network collocation to accelerate these low latency. So we can show all these results. We have many publications in the project that demonstrate these plots. Then finally, the confidential data broker would be the third pillar, the third big results of the project. Again, here we have this startup using Schoenauer technologies. That is again an open source project. And here we have a data broker that is protecting pipelines in genomics and surgery. There is an overhead versus vanilla techniques, because you are using enclaves. And also these technologies are offering you a file shield and a network shield. So they are protecting the entire life cycle of data. And they have some overhead, but they are protecting from a large number of attacks in federated learning and traditional learning. So then I would finish now the explanation of near data. You see this third project around Lithops and Pyran.cloud. You have Praviga and the Elastic Stream Analytics Service, and we have confidential computing in Scone applied to the different scenarios, and we outline 3 trends. The first one is elastic near data processing for big data and AI. It's very important to process data elastically. The same for serverless streaming. I mean, we are also offering this elasticity for streams, and we are offering and trying to show in the future end-to-end confidential computing with zero trust in all the layers from cloud to edge in the entire continuum. And that's all. Thank you, and we move to the next project.
Here. Oops, so now we have setup. So we have Genio Marinelli from the Europe.
Thank you. Hello everyone, I'm Eugenio Marinelli from Eurecom, research center south of France. I'm very happy to be here to present our project CycleOps. So CycleOps is a 3-year project run from 2023 until the end of this year. And what CycleOps stands for is scaling extreme analytics with cross-architecture acceleration based on open standard. So what does this mean? So to give you a little bit of context, nowadays AI is increasing in popularity, and so is doing the demand for higher performances. Now, one way to optimize and push the performance of your AI algorithm is to rely on specialized hardware and offload part of the computation to this hardware. For example, you can use a general purpose graphical processor as a GPU to optimize some AI application, or you can opt for a custom ASICs processor. However, the problem with this is that it doesn't matter what architecture you are using to accelerate your workload, you will end up to be stuck with a proprietary software stack of specific vendors. For example, if you decide to accelerate your code with NVIDIA GPUs, you will have to use NVIDIA CUDA as a programming language or the library that they develop. So the vision of CycleOps is somehow to democratize the AI acceleration, by creating an open ecosystem based on the 2 open standards, SYCL and RISC-V. So SYCL is an open standard that defines a programming model that allows your program to be parallelized and accelerated on any kind of hardware architecture, regardless which is the vendor for that device. On the other counterpart, RISC-V is an open standard that allows to define a royalty-free instruction set architecture, so that you can create your own processor using an open RISC-V instruction set. So, of course, we wouldn't start CycleOps if there weren't opportunities and challenges to overcome. So the first opportunity is concern RISC-V instruction set. So RISC-V is gaining momentum as an AI acceleration tool, but the implementation and verification on your custom instruction RISC-V is still largely a manual approach, which means that when you define your custom application, for example, your custom instruction, for example, to compute a dot product or 2 matrices, you will need to verify that everything works properly in the code, but also at the hardware level. And so far, everything is done manual. There are no tools to automatize this process. The second opportunity is also SYCL is gaining momentum as a programming model. If you think about it, it's the dream of every developer writing a code once that can run on any type of architecture. You don't have to write your code for NVIDIA GPU and a different version for Intel GPU. You can write the code once and run it everywhere. Of course, the challenge here are the fact that the backend compiler for RISC-V is still not mature in C++. SYCL is at its early stage. The SYCL runtime support doesn't support still efficient scheduling, where you can, for example, decide how to automatically decide how to flow the different parts of the code to different other architecture. And so far, there is no SQL interpreter for an interactive data analytics. To make an example, if you often when you deal with data analytics, you use Jupyter Notebooks, where you use few Python code at a time. But with you cannot do this with the SQL because there is no SQL interpreter available. And the third opportunity is the fact that SQL comes with some library. For example, we have SQL DNN that is an open source library in SQL for accelerating deep neural network. But the number of libraries in SQL is still limited if compared to proprietary solutions. So to overcome these challenges and exploit the opportunity, we put in place a SQL stack. So on the bottom, we have the infrastructure layer, where some partner of the project created a micro data center where we have different type of hardware accelerator, including a RISC-V accelerator developed by some other partner of the project. On top of the infrastructure layer, we have a platform layer where we find SQL compiler, SQL runtimes, and SQL interpreter that will compile and run your SQL code on top on a different hardware accelerator that you have on the bottom. And on top of the platform layer, we have all library. We are developing libraries and tools to address different use cases. What are these use cases? The first one is about autonomous system. It's handled by one of the partners. This project is called Coldplay. They are developing neural network accelerated library for neural network to address some algorithm, to accelerate some algorithm that are common in autonomous system. The second use case is about precision oncology. So Axelom is a partner of the project that is developing a genomic accelerated library written in SQL to provide outcome result and ad hoc treatment for cancer patients. And the novelty is the fact that there are so far no open source hardware accelerated genomic pipeline available. And the third use case is about high energy physics. It comes from CERN. At CERN, they have this particle collider where every experiment generates petabytes of data that they need to analyze. For this, they have an internal library called Root, but there is so far no support for SQL. So they are implementing a SQL support for the Root library. So far, this project has been out for 2 years, and those are the first results and highlights of this project. The first result, we created a one API construction kit, which is a tool that allows to compile SQL code and offload it to RISC-V accelerator. The second set of tools we produce are called the adaptive path and CAM2, that are tools that allow to profiling your code and do a performance modeling across several hardware architectures. And the third result is SQLDB, a database engine that we are building from scratch at INRIA, and where we are investigating what happens when we have a high-level language as SQL and a RISC-V hardware accelerated when it comes at data analytics. So that's all for me. Thank you.
Thank you so much. So now we're going to have a bit of a reflection of some of these highlights that were presented. We'll go over what was talked about, and then there'll be a bit of a discussion concerning some of these highlights and potential recommendations. So here's just a list of some of the highlights that were mentioned during the presentations. The presentations will be online later, so I won't read this to you. But as you can see, there are several things that have come out of the project, several technologies that are very positive coming out of this funding 2 years in, right? 1 year left to go. With that in mind, we also have to think of some common ground, right? All of us try to work towards extreme data solutions. But how do you all think the proposed solutions actually contribute to handling extreme data? Tyler, maybe you want to?
Extreme data.
Yes.
So basically, if I look at last question, I think
the thing that ground technology for all these projects that we have here. So I remember having from, let me, if I remember the project, Emeralds, we have the smart cities, we have transportation networks, so they can be modeled as graphs, we need graphicality underneath that. Data center digital twin, so we model Ginecta, but we can go to Barcelona and help them, improve their operational sustainability using graph processing. We don't model RISC-V processors at digital twins, but okay, that could be the next project, if I can throw the ball. Locality near data. I had discussions here in the past of graph partitioning, so how can we partition graphs, to do locality-based data processing, but that also is a challenge. And extreme data is everywhere, AI is everywhere, so I've seen, we don't have that, but AI as a way of compressing extreme data. So rather than being a general model that can predict things, we just embed into a AI neural model existing extreme data information. So you memorize the data so that you can extract it, at a better point. So that's my take.
Adra, maybe you want to say something?
Yeah. No, it very much in connection, like Radu said. So we all have in common that we are dealing with very complex data formats. I mean, this is not like the structured vast databases. It's something very complex to deal. I mean, either you are dealing with genomics that are very complex blobs, or we are dealing with real-time streams, like in many cases here, or we are dealing with complex graphs, or I mean, all these formats, spatial formats, even in smart cities like cloud-optimized geotips, Sentinel images. I mean, all these huge blobs required for all of us was very complex to deal with this data. So on the one hand, data management would really be efficient in dealing with them. It's rather, I mean, with these huge graphs, he has expertise that no other project has now to deal with these huge graphs. And we are also trying to really work on the data management of these very complex data formats. And these are like the intersection of our project is dealing with this and orchestrating how the compute resources operate on them. Here, I mean, our expertise on this data management on the 5 projects, it's super important because the formats that we are dealing are especially complex, not because of volume, low latency, and also the complexity of the formats themselves when dealing with this composition. So really, AI community could benefit from us a lot, from the expertise of these 5 projects. It's not really easy to deal with these big data blocks.
Yeah, sure, continue.
Yeah, so they said pretty much everything. One things they have, all these projects have in common is that they are dealing with extreme data, and in most cases you are trying to accelerate the process in a different way. But I mean, the common ground is that we need hardware and way to handle the processing of this large amount of data.
Yeah. I mean, I think another highlight, if I can interject here, and I think we were talking about this before, Bahare, is also just different applications of the extreme data, right? And very different use cases. It's common to say that extreme data is everywhere, and now you're showing through your projects all these different applications. I don't know if you wanted to say anything more on that, or
we probably cover everything. Yeah, we have the same situation in urban mobility. With again, we're working with graph-based data. We're working with extreme scale data. So dealing with a large amount of data, and also we have to provide it for real-time answers, for real-time applications. It's not easy. And also it's, we are trying to solve the situation, solve the problems for some cities. But again, we probably face a bit new challenges for different cities, for different situations. So we try to solve the problem, but it's not ended, and it's open problems for next to this for even more accurate, more real-time situations. So
Great, thank you. Basically, I mean, we kind of discussed some of these topics beforehand once we saw each other's presentations. And so some of the highlights, as we're going to present later in the afternoon, will be along these lines, right? So what are real highlights that all of the projects really can say that we share, right? So building a resilient and scalable compute infrastructure for Europe. So all of the projects are advancing along these lines, like helping to advance seamless orchestration across cloud, edge, and HPC environments, right? This is really important. All of these different technologies, finding a way to work across them. Also working towards strengthening AI trustworthiness through secure and high quality data. The projects are helping to ensure accuracy, fairness, and security of AI-driven decisions by improving data discovery, filtering, and processing. And as we were discussing before, I mean, AI works well when the data is accessible, correct, of good quality. You have to catch that. Right? And the last kind of highlight is fostering European leadership through open collaboration and innovation. So as you saw, some of their own results and highlights during the presentations, projects are really prioritizing having open source toolkits, data sets, platforms, and this is to enable broader industrial adoption and community-driven advancement. So this is for everyone. These are the values that we say that we contribute to, and these projects are working towards that. And also just in general, then supporting Europe's commitment to digital innovation and ensuring that research outcomes translate into real-world economic and societal benefits. So does anyone, these are things we've talked about, and I think unless you have comments, we can move on to challenges. There'll be a chance for questions at the end, but I think, no? Okay. So yes, moving on to challenges, because challenges still exist. They're 2 years into the project. We see, okay, we were running the direction we wanted to go. Now what are we running into in terms of obstacles? So these are some of the challenges that were mentioned during the presentations. Once again, the slides will be available, so I won't read this to you. I mean, they were presented. These are roadblocks that are being hit by different projects. But to make this more discussion oriented, I would say maybe open the floor a little bit here to the panel. How are projects tackling the trade-off between data quality, security, real-time processing, and what gaps do you think still need to be addressed? Somebody wants to start? Hey, Adra has been nominated to start again.
It's easier to be the first person because steal your ideas. So security definitely is an issue, and when we do AI, one of the things that we try to say, okay, don't share data. Yeah, we don't share data, so we train local models locally. On private data, maybe you use homomorphic computing, which is slow, by the way, but you still work on encrypted data, and then you just share the model. Yeah, you just share the model, people share the model, and you do some model aggregation. Still, data is non-IID, non-independent and identically distributed. It means that some communities may be overrepresented in the data. It means even if you share the model, they can still be the target of certain attacks. There are proofs of model inversion. Yeah, so I think Netflix released some data set, and they were able to unveil the identity of the people watching certain movies. Yeah, just because of the properties of a certain data. So model inversion, and also there is another one. Anyway, it doesn't matter. So basically, things like differential privacy, are very important to targeting the future. So applying noise to certain models so that you can make sure that while you share a certain model, basically the identity of a single individual in the training data set cannot be disclosed, by doing some reverse engineering on that model. Yeah. So things like differential privacy, homomorphic computing, applied to federated learning is something that still requires to research, because there is a trade-off, of course, noisy to the model accuracy. Yeah. So quality of the data, security, and
real-time process.
Yeah, real-time because it's slow. Yeah, noisy, homomorphic, everything is slow. Yeah. So it's a trade-off.
Yeah.
Yeah, well, from my side also about these challenges, one important is efficient resource provision. I mean, the problem with this big data is that cluster technologies are not the solution, because I mean, you either over provision or under provision. So you really need elastic data management and elastic data process. So you really need, in cloud edge, you cannot tell them, the data scientists, create a huge cluster and solve the problem. I mean, you really need to orchestrate finally and optimize the resource provisioning, and we must do this problem for them. So we must really be able to partition data in elastic ways, to provision the exact amount of resources that you need for that problem. Because if not, it's really costly to process these big amounts of data, and over provisioning or under provisioning can be super expensive for the people or super inefficient to process.
From project side, I can say yes, we have data that we need to that we can analyze. But first of all, there is some security and sensitive data hinders that we have to be careful about anonymized data, because we began tracking mobility in cities, so it's sensitive. And also, we have a large amount of data, but it's mobility and it changes stage by stage. So we have to retrain models step by step. And yes, we have data trained, but even in each, I don't know, maybe a couple of months, we have to again retrain all the models. So from us, yeah, it's the challenges, but we have to still continue working to keep all models updates. Yeah.
So on the side of our project, I think one of the challenges we faced is the fact that the technology that we are using are still new at the beginning. So everything we do, we have to build it from scratch, let's say. So we don't have, at the beginning, we don't have a backend compiler for SQL, for a RISC-V accelerator. And so we have to build it. Also, when you compare to the proprietary solutions that are out there, by the number of libraries and how they are optimized, because they are there since decades. It's very difficult to keep the pace with those technologies, but we are, I think we are doing very well to building everything from scratch and trying to keep up with those technologies. And for specific case of the genomic pipeline that we are dealing, there is also a problem of since we are dealing with genomic data, there is question about privacy of the data, and it's difficult to get the data to test your program. So this is our side.
Okay, so from extract standpoint, first of all, on the security side, in the case of Venice that I presented, since we are working with possibly sensitive data, since we are citizens, first of all, one thing we need to do is work with Adra-e data, so we are not really identifying people. This is one solution, and then we are also using homomorphic encryption, as Marc said, of the models and of the data. But we think that we have to be reminded that the trade-off is that real-time constraint and the processing can be delivered by some other partners. So if you want to use all these security measures, we have to be reminded that the processing time will probably be taking more time. And then on the real-time processing as well, I feel like the hardware can keep increasing and can improve, but the toolkits need to go in as well. So, for example, tooling such as what Pedro said about how we ingest the data, something that we need to keep pace with the hardware improving, and also, for example, in our case, since we are using prompts, identifying which part of the steps can be parallelized and making as much use of the infrastructure as possible. And in order not to over-provision, so we have a complete infrastructure, we need to take as much use as possible of it in order to deal with the real-time constraints.
Okay, so I mean, you guys have really made big jumps, but are hitting some kind of the same issue, so that's interesting to see. And what do you think about challenges that have emerged integrating different technologies? So we're supposed to work across the compute continuum and consider different technologies. So have you seen specific challenges that have emerged integrating AI, HPC, edge, fog, cloud computing? And how do you think EU funding can better support this cross-technology synergy? That's a big one. Sorry. Who wants to start? Pedro, maybe you were talking about this earlier. Okay.
I can go here. So about the integration of AI and the other technologies, I think that here really the problem, a joint problem that we are having in the same projects, in the different projects, is that I mean, data is so important for AI technologies, and we are neglecting this. I mean, data is the core of AI, and really the technologies like without data, Europe is not going to do anything. And here, the problem with integrating this data is that the data hubs, the libraries, the security, the entire stack, the hardware accelerators, we are not yet there. I mean, these projects have started research here, but there is a long trend to finish with that. And we are still trying to, in graphs, in real-time streams, in hardware accelerators, we are trying to, like extract names, we are trying to extract information from this data. It's like oil, because it's under the earth. It's very difficult to access. The technologies are not yet ready. And Europe is not ready to access these technologies today. I mean, we have provided some solutions that must be continued because, I mean, all of these projects have really clear research challenges are not yet solved. I mean, even related to the last one, even, I mean, the data hubs, I mean, Amazon in the cloud, you have like open data sets, like the AWS registry for open. I mean, we don't have that because this is in US East. I mean, it's in the US. So if you want to compute close to the data and you want to do AI close to this data, you have to execute it in the US. So we need data to be available in Europe, in cloud, but in AI factories. I mean, we need the data here, and we need the technologies that we are trying to create here to access this data from AI platforms. And we are not there. And it's a big gap here in the future to solve this problem.
Yeah, I think that's a really, really good point. I think sometimes we get so excited about all the technology and we think like the core needs to be strong in order to be able to go further.
So in the integration area, I take it a different standpoint. So it's between hardware and software. These two worlds were completely like orthogonal in the past. You know, we had the hardware community that, Moore's law, they were chasing the Moore's law, every 18 months, twice dense transistors and twice better computers. And software was chasing after hardware and struggling, and they had bad reputation. Software is spaghetti, software is bad, it's buggy, it doesn't perform. Efficiency of hardware use is very low. And now we are at a turning point where Moore's law clearly for the hardware is kind of a threshold, so they cannot go beyond. And AI in the software is coming. So for the first time, hardware is paying attention to software. So they don't go with the arrogance, of Moore's law, just go and, we don't care about the software people. These two communities now are integrating together. So AI factories are emerging. So I think it's a very good opportunity to have now a more efficient and more sustainable way of doing computation.
Okay, from our side, as you mentioned, that there is a lack of data developing in Europe. Okay, we have data. We're currently working on data generated in European cities. But for example, we had there are open access, but it's not easy to use. And during our project, we try to make it easier for people to use it. It's large volume data. It's raw data. It's not clean, not even clean for read it and save it in your PC and use it. So we are trying to improve these open source data sets and make it available for others. But we need more data sets. For example, we're currently using that for I don't know, public transportation data, but we need it for more data. I don't mean sensitive data, but for example, for different movements, for different cities, for different part of the highways or urban areas. We need more data and make it available for researchers. No.
Okay,
just well, I very much agree on everybody said about the data, just really from another perspective. On the HPC integration with, well, first of all, on the edge cloud and computing, I would say that what we found out in the start is that for edge computing, usually a technology that we don't use to expect everything is Kubernetes. What we found out is that for the edge, although there are many possible solutions, sometimes they are in beta versions, sometimes they don't deal well with Kubernetes. So while you can have complete solutions just for the edge, sometimes they don't integrate well with cloud or just plain vanilla Kubernetes. The other thing I would say is that for HPC, it's still a challenge to integrate it well with Kubernetes, because usually on HPC you have QoS protocols, such as SLAM or other protocols. In that line on BSc, we are working in a connector to integrate Kubernetes with SLAM, but it is we have to remote there, and it's quite challenging to use Kubernetes with HPC.
Thank you. And we kind of touched on this about how can European data sources be better leveraged across projects. Pedro, I think you started with that. I don't know if you wanted to add anything or you should. Does anybody have anything?
Yeah. Yeah, one thing that I said is that I'm surprised that AI factories should also move on that direction. So AI factories should become data hubs, and they are not yet there because they mainly are hardware and software providers. So they are offering you storage or computation, not data. I mean, they should become data providers, because if you are creating AI factories and you are going to run training on these AI factories, you need them to offer data sets. I mean, they need to attract data sets. I mean, the ones that they were saying about cities, transportation, genomics, they have to offer that, and they have to change mentality, because HPC people or regardless, sometimes they are like tied to all technologies, and they have to provide also multi-tenancy and object storage and things like that to enable these data hubs in their AI factories. So really, we need in Europe these AI factories, but we need them to become data hubs, and with the technologies that we are creating to access these very complex data sets in the different. So I really think that there is much effort that must to be done, and if you leave AI factories to use the traditional technologies, they will continue doing the same, and they will not offer AI practitioners what they need to really break an edge or doing interesting research.
Does anybody else want to add to that, or no one to defend the supercomputing center? That's okay. Okay, great. So kind of based on this discussion, we came to some conclusions about what potential challenges we could share with the Commission. I think one of the first things we talked about to make clear is there is no AI without data. Good data, without accessible data. I think that's the main take home for us. But then the idea is also to, we would suggest investing in extreme data research challenges like model explainability, neural symbolic AI, HPC, and also in the coming funding and calls and everything, so that doesn't get lost. Also supporting interoperability, that was one of the key things that people kept mentioning. Also RISC-V, we see a move towards that. And interoperability between AI, HPC, and cloud edge computing to enhance efficiency. And to expose, deploy extreme data sources in major European HPC cloud locations to ensure near data computing. So like Pedro was saying about the AWS registry for open data that is available in the US, but not here. So those are our main takeaways after really talking as a cluster and thinking about what we're running up against in our projects. So I think, yeah, that's it for the presentation and the panel, but I don't know if anybody has any questions for the panelists. I mean, if not, I know it's going to be lunchtime, so please feel free to approach anybody if you have any concerns or anything, and we'll be presenting in the afternoon in the plenary about the highlights and the challenges that we discussed. So thank you. Here's a QR code to some information about the collaboration we've been doing together. This is the second panel we've had together as a cluster. The other one was at the EDDBF in Budapest. And we are trying to work together to find common things to highlight, things we have in common, but also how we approach different challenges. So please follow us to stay updated on our projects, and thank you for your attention. Good on there.